Hello and welcome back to Mr. Powers Teaches Algebra. That's what I'm doing, teaching algebra. Ooh, looks all right. I'm gonna go a little more. Okay, so it's welcome. It's great to have you guys, and let's do this. So last time we met, we went over this fun little operation here. Let's say I had some base raised to some fractional or rational exponent. What does that mean? That means I could rewrite this with a root. That denominator is the root. So I could write it either like this, the nth root of b to the m being the numerator of my exponent, or I can go the other way around and just say it's the nth root of b all raised to the mth power. I could do either one. Now, I'll be honest with you, most of the time I would prefer to do this one if I can. You can't always do it, but if I could take the root first and I know the root, I'm going to get a smaller number. If I can't do that, well, then I'll do this, right? It's fine. And I believe the problems that I assigned you, most of the time, are probably going to be messing around with this one here. But it really doesn't matter. If one works, great. If it doesn't, try the other one. That's all you got to do. So without further ado, now let me go ahead and just say we got a few properties of exponents now that we can expand upon. And we've messed around with these in the past. You should have seen these before. But just to make these really clear now, if we have the nth root of a times the nth root of b, what we got is the same as the nth root of a times b. And vice versa. We can go from a product under root to separate roots, a product of separate roots. So, oops. And I got to set these settings up. You get OneNote, you set it up, and then Microsoft says, hey, guess what? We're not supporting that version anymore. Let's update it. And then I remember turning off all these options. And now I'm like, oh, yeah, it's doing all this stuff I don't like. Okay. Now, what do we got? So we have this. This is a property we have. Now, I'm going to explain this property, and then I'm not going to explain the rest. Now, why is this true? All of these properties we have with roots, we got a lot of properties with roots. All the properties we have with roots really come from the fact that a root is an exponent. Remember that this is just a to the 1 over n. What this is really b to the 1 over n. And we have that property that says I can rewrite this as a times b to the 1 over n. Because what happens when you have a product raised by an exponent, you can distribute the product. Or you can distribute the exponent throughout the different factors in the product. So there we go. So a lot of these properties of roots come directly from properties of exponents. This one in particular is a very, very useful one we're going to be using. Okay? Now, without further ado, let's do some examples. Okay? The first example I want to do is this guy. Okay? And it says express 4 to the 4/3 in simplest radical form. So no matter how you do these, what you're going to want to do is rewrite this using the property I explained already. So what property is that? It's like here, the numerator is the power, the denominator is the exponent. So what I got is 4 to the 4th to the cubed root. I'm going to cube root 4 to the 4. That's what I have. Okay? And now I want to reduce this. I want to simplify this as much as possible. So there's one more property that I forgot to talk about. And that is a very important property, and that's this one here. Let's see here. I need more colors. Let me add a color here. Let's get orange. Do I have orange? Have a light blue? Let's try a light blue. All right. Okay. And so let's say this property here. If I have anything, it's too big. If I have anything raised to the nth power, let's say, and then on top of that's raised to the 1 over n, guess what? That is x. This is the same as saying the nth root of x to the n is x. The nth root undoes an nth power. That is a very, very important property as well. Okay? So when I see something like this, that's the idea. If I want to reduce these, that's what I'm thinking of, is that I need that to happen. Now, we can kind of, here we can definitely do that. It's actually really, really easy if I wrote this down right, and I did. And that is to say, in this case, I could rewrite this as 4 to the cubed times 4 to the 1 underneath my cube root. I can split that 4 up. And why do I want to do that? Well, I want 4 cubes under my cube root, because of what is the cube root of 4 cubed? It's 4. That's going to let me take out as much from the root as I can. That's the goal here, is I want to take things out of the root. I can break this up even more. I get 4 cubed, the cube root of 4 cubed, times the cube root of 4. And where do we get that from? We get that from this property right here that I just mentioned, is I can break this up. Going from the right to left here, we can break that up. And then using the property I have written there in blue, we know that this part in the front is 4. And then this is, well, I can't reduce this, so I'll just leave that as the cube root of 4. And that would be my answer. All right. There it is. Now let's try another problem. Well, that one's just way too easy. It's boring. Oh, I guess it's not that boring. Okay, let's do this one. 27 to the 4th raised to the 1/3 power. Now that one's really similar too. Hold on one second. Here's a good example. Let's say we have the 4th root of 5 to the 14th. And actually, no, I don't like that one. I want to do 5 to the 15th. Now that I think about it. Let's do 5 to the 15th. And you'll see why. What I want to try to do here is kind of show you guys a shortcut. And then the next video we'll do some more examples, and then I'll do another one with technology. You guys love that. Actually, just real quick on this one, if you wanted to check your work on this, no. We'll technology on the other ones. So I'll make a video where we check these with technology in a second. So let's say for this guy, and actually on this one we would have started off with, you know, what this would have been 5 to the 15th over 4. Okay, so we started with that. I'm like, okay, first thing I'm going to do, rewrite it as a root. Now I need to reduce the root. How do we reduce the root? And that's what these problems are about. Simplify this in simplest radical form, which means I need everything out of the root as I can. Well, since I have a 4th root, and I got this property here that the nth root of x to the n is x, I want to get my 5s in groups of 4. This is the way to think about it. 5s in groups of 4. So I'm going to rewrite these. I'm going to say, okay, the 4th root of 5 to the 4th. I'm going to do, okay, times again, the 4th root of 5 to the 4th. All right, how many 5s I got so far? That's 8. 5 to the 4th times 5 to the 4th, that's 5 to the 8th. I need to get 5 to the 15th. So let's do it again. Times the 4th root of 5 to the 4th. That's going to be 12. I got 3 left. So then I can say, well, that's really just times 4th root of 5 to the 3. Whew. Now there's a reason I'm doing this. So hang with me. 5 to the 4th. 4th root of 5 to the 4th. How many of those did I get? I got 3. 3 times I could do that. But then I had 3 5s left over. So what do we get? We get 5 times 5 times 5 times the 4th root of 5 cubed. And I'm going to end with 5 cubed. Ah, shoot. I got 3 5s. Times the 4th root of 5 cubed. Okay, so there's a reason I wanted to show you this. And actually, these two examples here will kind of show you the shortcut. Okay, so there's a shortcut for doing this. When you're doing these by hand, there's a trick. Because the whole idea is like how many, I'm going to get groups of 4, and I have 15 of them. How many are there? That language should ring a bell to you. And it should be this. Your little ring a bell, oops, is, come on, okay, is that idea is just saying, hey, 15 divided by 4 is what? Because I'm getting groups of 4. That's what I want to do. 15 divided by 4 is 3. Remainder, 3 times 4 is 12. 15 minus 12 is 3. 3 remainder 3. So what that tells me is that this 3 here, let's do it this way. This one. This 3 here, actually, let's do it like this. This 3 is how many 5s I'm going to have on the outside of the root, and this 3 is how many 5s I'm going to have. Let's use a different color for that one. This, no, it's not good. Here? Yeah. This 3 is how many I'm going to have inside the root. Okay? Right there. Does that work in this example up here, where we did the cubed root of 4 to the 4? Same thing. I will need to get, since I'm doing a cube root, I need to get groups of 3, and that's what I did. I had, well, one group of 3 plus 1 left over. What is, so if I'm looking at that over here, what is 4 divided by 3? It's 1 remainder 1. So what is that? That is, I'm going to have 1 4 outside the root and 1 4 inside the root. And that is what happened. Let's see here. Got to get better highlighters. Something a little easier. 1 outside the root and 1 inside the root. That's the shortcut. That's the trick. Okay, so that's 14 minutes. I'm going to do one more video with a much trickier, much more complicated example, and then we'll show you some ways you can check your work using Symbol Lab. So until next time, enjoy doing math.